Alright, so today's lecture is going to be a shortened version of hybridization, or the easy way to do it. So to start, what does it mean when you have an Sp, an Sp2, or an Sp3 hybridized molecule? Well, let's start with an Sp3 hybridized molecule. For example, two carbons single bonded with 6 hydrogens around it. So you have a single bond. Now, how do you know that this is an Sp3 hybridized molecule? Well, an easy way to tell is to count the number of groups around, let's say, the central carbon, or a central molecule. So, that says just the number of groups around a molecule. It is the easy way to determine a hybridization. So let's check out this carbon. It has 3 hydrogens and 1 carbon bonded to it. So it has 4 groups total, meaning it is going to be Sp3 hybridized. When a molecule, or when a carbon, or any central molecule has 4 groups attached to it, it is going to be Sp3 hybridized. And same with this one. This one has 3 hydrogens and it's single bonded to carbon. So it's going to be 4 groups, making it Sp3 hybridized. So let's check out an Sp2 hybridized molecule. Here, notice that I have a double bond. So what does this mean? So we have a central carbon again, with 2 hydrogens now, and a double bond to carbon. Well, this double bond only counts as a single group still. So we have 1, 2, 3 groups attached to it. And when you have 3 groups attached, this carbon is said to be Sp2 hybridized. Same with this one. And an Sp hybridized carbon could look like this, where you have 1 hydrogen group and 1 carbon group, because the triple bond still only counts as 1 group. So you're going to have 2 groups attached, making it Sp hybridized. Well, what does this mean? Well, based on this, we can tell bond length and bond strength. So, which of these has a longer bond length, meaning which has longer bonds between the molecules? Well, to do that, we're going to need a little bit of background information, and that means we need to know the percent S character of each bond. So, let's see. You know S orbitals hold 2 electrons, p orbitals hold 6 electrons. In the s orbital, these electrons, the electron density, I guess I can write that again, electron density is going to be closer to the nucleus. So when something has an s orbital, the electrons are going to be wanting to be closer to the nucleus, meaning that the bond length is going to be shorter. And then vice versa, when you have a p orbital, the electron density is going to be further from nucleus. So, with that said, which of these has, let's do bond length first. Which of these has longer bond lengths? Well, let's start with this one. When you have percent S character, well, how do you figure out percent S character? Let's start with that. Here, you're going to have 1 S and 3 P's. So this is going to be 25% S character, 75% P character. You have 4 parts. 1 part is going to be S, 3 parts are going to be P. Here, it's going to be 33% S character, because you have 2 parts P and 1 part S. So it's going to be 33%, and then 66% for the P. And here, you're going to have 50% S character in an Sp hybridized molecule, because there's 2 parts, 1 part is S, 1 part is P. 50%. So, like I said before, percent S character, the more S it is, the closer the electron density is to the nucleus, which means it's going to have bond length. How does that affect bond length? When you have less S character, the electrons are going to be further from the nucleus, meaning that bond length is going to increase as you get less S character. When you have a lot of S, the electrons are going to be close to the nucleus, so this hydrogen, this carbon, are going to be closer to each other. The bond length won't be as long. Over here, the carbon-hydrogen bonds are going to be a little bit longer, not dramatically longer, but a little bit, because the electrons are going to be in part p orbital, part s orbital. You only have 25% s character, meaning that these bonds are just going to be a little bit longer. Bond length is going to increase as you go from sp to sp3. Bond strength is going to be the inverse, where as you get electrons that are closer to the nucleus, the electrons won't want to be separated. As you know that the nucleus is a positive charge, electrons are negative, and the closer they are together, they're not going to want to split. Over here they're a little bit further, and they can split a little bit easier. So bond strength between this carbon, this hydrogen, same over here. This one's going to be a little bit stronger because the electrons are just a little bit closer to the nucleus. So bond length increases as you go from sp to sp3. Bond strength increases as you go from sp3 to sp.